4 points charges Q, Q, Q and Q are placed at the corners of a square of side A as shown in the figure. So this is the figure they are given. Okay. Find the resultant electric force on a charge Q. Okay. The resulting force is for this one means here the code mentioned is the capital Q. That means the resultant force will come like this. So this is the resultant force along the diagonal. Okay. If I am going to take the notation here, this is a and this is a B, this is a C and this is a T. There, here it will come for, this is there given it is A, then this becomes, the diagonal becomes A under root of 2 according to the Pythagoras theorem. Okay. Then I can take this value, it is 2, the force is here it is 2 and this value it is a F3. Then if this is the second force and if this is the third force, then the resultant force becomes F2, 3. This we need to find. The resultant force we need to find here. Okay. Now, force due to the other charges Q. Force due to other charges Q, F1. F1 force due to the other charges Q, F1 is equal to 1 upon 4 pi epsilon naught into Q square divided by A into under root of 2 whole square. So this becomes 1 upon 4 pi epsilon naught into Q square divided by a root and square will get cancelled. Then this becomes 2A square. This is along AC. This is along AC. And force due to the charge Q at point B. At point B, we can write it as F2 is equal to 1 upon 4 pi epsilon naught into Q divided by A square along BC. Along BC. Force due to the charge Q at point D. At point D, that is F3. F3 that is equal to 1 upon 4 pi epsilon naught into Q divided by A square. This is along DC. Along and DC. The resultant of these two equal force, that is the 2 and 3, the resultant force is given by, that is F23. Resultant force F23 is equal to 1 upon 4 pi epsilon naught into Q under root of 2 divided by A square. This is along AC. Along AC. The net force, the total force, net force net force. Charge Q at point C. At point C is write as F is equal to F1 plus F2, 3. This is 1 upon F4 pi epsilon into Q divided by A square into Q by 2 plus under root of 2Q. This force is direction along the IC. So this is the direction of force. The total force is, this is the equation. Find the second potential energy of this system. We know that the potential energy of the system is, we can write the equation as is equal to 1 upon 4 pi epsilon naught into 4 times of Q upon A plus Q square upon A into under root of 2 plus Q square divided by A into under root of 2. Then if you simplify this one, that means if you take the common factor as in the denominator, A is the common factor. If I am going to take it as a common factor, then 1 upon 4 pi epsilon naught A times of 4 Q, if I take a common factor, plus Q square divided by under root of 2 plus Q square divided by under root of 2. So this is the potential energy of the system. 3 points charges Q minus 4Q and 2Q are placed at the vertices of an equilateral triangle ABC of side L as shown in the figure. Obtain the expression for the magnitude of the resultant electric force acting on the charge Q. Okay, here, okay, I just zoom this image. You can see like this. Okay, now if you are going to apply the forces, I would take, this is the force 1. The force 1, if acting in direction like this, then this is the force 1. It is acting like this. It is F1 force. And this is the force 2 acting like in this direction. It is the force 2. The force 2 acting on this direction, that is F2 bar. Okay, here F1 bar. Then this is the F3. Force 3 bar. Okay. And already the notation A, B, C, everything details is there. This is the L they are going to give on here. Okay, now we are going to find the force on charge Q. Force on charge Q due to the charge of 4Q. Due to the charge of 4Q. Then we can write it as F1, that is the force F1. F1 is equal to 1 upon 4 pi epsilon naught times 4Q square divided by L square. This is along the direction AP. Along the direction AB. So I can write here, it is along AB. along AB. Similarly, force on charge Q due to the discharge to Q. Due to the discharge to Q, the force on charge Q, that is F2, is equal to 1 upon 4 pi epsilon naught times 2Q square divided by L square. This is along CA. The forces F1 and F2 are inclined to each other at an angle of 120 degree. This angle, this F1 and F2, it is an inclined at an angle of 120 degree. If it is an equilateral triangle, then the inside triangle angle is equal to 60 degree, and the external angle, this angle definitely which is equal to 120 degrees. Right. Then this we can call it as a theta. This theta is equal to 120 degree. Then force F1 and F2 are inclined to 120 degree. F1 and F2 are inclined at 120 degree. Then the resultant electric force on charge F is equal to under root of F1 square plus F2 square plus 2 times F1 F2 cos theta. This theta is nothing but the inclined angle, that is 120 degree. Then if we substitute the value, then F is equal to under root of F1 square plus F2 square plus 2 F1 F2 cos of 120 degree. Okay. Then F is equal to F1 square plus F2 square minus 2 F1 minus F1 to F2 under root of F1 square plus F2 square minus F1 into F2. Then we know the values, substitute the values, we get the answer 1 upon 4 pi epsilon naught into Q square divided by L square under root of 16 plus 4 minus 8. Then the final equation is F is equal to 1 upon 4 pi epsilon naught into 2 times, that is 2 root 3 Q square divided by L square. Three-point charges Q, minus 4Q and 2Q are placed at the vertices of an equilateral triangle ABC of side L as shown in the figure. Okay. Now we need to find the second one. Find out the amount of work done to separate the charges at infinite distance. Okay, I'll zoom this image. So already we discussed this one in the previous video, the same thing. With respect to the same equation, I am going to extend this one. That is, work done is equal to work done is equal to 1 upon 4 pi epsilon naught into Q square divided by L times, here the values they are given, minus 4 F1 plus 2 and 2 times of F1 F2 cos theta, that 2 times of 4 is the thing but minus 8. Then if you are going to simplify, 1 upon, this is minus 4 plus 2 minus 8, this becomes minus 10 Q square upon 4 pi epsilon naught into L. Then final equation is 10 Q square upon 4 pi epsilon naught L. If I'm going to simplify this one, 10 and 4, it is a 5 by 2, 5 Q squared upon 2 pi epsilon naught L. This is the work done.